So yesterday we talked about FIFO, fair queuing, something. So today we'll see a little bit in depth. So how queuing works basically. So as long as you have enough bandwidth in your transmit ring, so basically whatever we are doing here, we are talking about, that is your software queue or queue depth. So let's say. My pen is not working. We only control out software based queue, which is your outbound queue. Okay, so this is the software based queue connected to your TX ring, and this is your incoming. Okay, so in FIFO, this will be your head of the queue. So will be managing only this one. We don't have control over there. So if your clocking rate, it depends. So TX ring will always depends on your clocking rate. If it is set to 6400, it will be acting as a, means it will transmit 6400 bit per second. If it is 12800, then it will transmit your 12800 bit per second. Okay, so if so we don't, so leave this part. We don't have, this is serialization delay. It only depends on how your interfaces or drivers are converting your data traffic into the media. So that is serialization delay. We don't have control. What we can manage it, that is your software based queue. So as I told you, like every interface will have its own buffer size, and that we generally call software based queue. So this will be the head of the queue. This is the tail of the queue. Ah, tail of the queue. So generally, if I'm receiving a traffic in a sequence, let's say 1, 2, 3, 2, 3. In FIFO, your software based queue will order all the traffic in the same way. 1, 2, 3. Okay. And let's say if at the same time, so at that time your TX ring is empty, your this queue will not perform any activity. So there is no congestion or nothing is there. So your software queue will not be in act. But as soon as your TX ring is busy and it's transmitting it at its 100% of the bandwidth, then what will happen? Your outbound queue will be in act, and it will order your all the traffic as per the queuing mechanism. But in FIFO, there is no I would say it's a simple forwarding, first in first out. So let's say 1, 2, 3 is already in place and it doesn't have any uh, buffer which can receive the fourth one. So let's say at the same time it has received the one, another one, fourth one. So what will happen? It will drop that traffic, and that is called tail drop, right? So we even in some vendor we can see the tail drop directly. So this is priority queuing also. It does classification in behalf of your interface, per interface, and per protocol. Now, so per interface, per protocol base, number of queues. This is important again. So how many queues it will create per interface. It will create 4 queue. Okay. Scheduling is strict priority. Priority. Weighted fair. There is one more. It's again priority queuing strict. Delay guarantee. Yes, it provides a delay guarantee. Yes. Bandwidth guarantee. Yes. Okay. Sorry, it doesn't provide bandwidth guarantee. So no. And not recommended for voice because there is no bandwidth guarantee. Okay. So bandwidth voice is only we can use. So for voice we can use only that priority queuing algorithm or mechanism which allows to guarantee you both bandwidth and delay. Okay. So basically how strict priority works. So in priority queue, the oldest queuing algorithm it is basically which consists of 4 queue, which is predefined. Okay. High, medium, normal, which is equal to your default, and low. So if you apply this priority queuing in your interface, so there will be 4 queue by default, normal and low, right? Okay. The scheduler begins by emptying the high queue, begin with the lower queue. So instead, so it will start. So if it is receiving 4 different protocol, let's say you have prioritized it can define as per the protocol and per interface. So let's say you have defined voice is the highest or video is the highest. So what will happen? It will start forwarding your video traffic first until your high traffic is not completed. Other queue will not be uh, forwarding the traffic. Okay. So higher will be service first. Okay. When upper queue are completely empty, then only lower queue will be transmitted. The basic of our algorithm proved very successful handling real-time traffic, but it it posed starvation possibilities to the low priority traffic flows. So that was the drawback of this one. Okay. Then there was another one which was CQ. Okay. So CQ basically addressed the concern of traffic starvation for common in priority queue scenario by introducing round robin scheduler. Okay, so it provides the 16 queue basically. Okay, so if it is having a 16 queue, then you can have multiple queues in your interfaces. So let's see. So CQ is classification in base of per protocol. per interface base. Number of queue 16. Scheduler is round robin. There is no delay guarantee and bandwidth guarantee, and it is not recommended for the voice as well. Okay. Now if we compare it with the weighted fair queue. Okay. Okay. So weighted fair queue we discussed yesterday as well. So it one more thing I forgot to tell you guys. So how it works differently than FIFO. FIFO has only one queue, but weighted fair queue works. Let's talk about the fair queue first. What is the difference between fair queue and weighted fair queue? Fair queue, as I said, it is not applicable in Cisco right now because by default Cisco use weighted fair queue. Fair queue and WFQ. Sorry. So fair queue equally divides your all the bandwidth into your flows. Okay, as I told you, like it will serve your small protocol first, whoever is taking less bandwidth. So let's say your interface is a pipe. Okay, it's 100 Mbps speed, 100 MB bandwidth, and you are having 4 protocol, let's say. So it will divide your pipe into 4 different queue as per the flow. Okay, so let's say this is telnet, this is FTP, STTP, SMTP. So telnet, if it is telnet is taking 1 Mbps. Okay, so it equally divides bandwidth to all 4 queues, 1 1 1. Okay, now telnet, so it will make sure that the protocol which is taking lower amount of bandwidth, that will be that is not getting dropped. Okay, now FTP needs more traffic, so it can add one more. So it further, so let's say still it is having one more so still there is FTP need one more. So let's say SMTP needs only 3 Mbps, so it is done. So now it will equally divide with these two, whatever. So basically, so if you are receiving 100 flows, it will create 100 different queue, and bandwidth uh, distribution will happen on the behalf of lowest protocol. So it means the protocol which is taking lowest bandwidth. Okay, so this is how fair queuing works, but there is no guaranteed again. So if a protocol needs more bandwidth, or if there is any priority traffic it's coming, that will have the similar functionality, or the algorithm will treat that traffic as a same way. What weighted fair queue does, let's say the same example, 1 2 3 4. Okay, so let's say this is telnet, this is STTP, this is FTP, and this is SMTP. So let's say I have given SMTP higher priority, so it's coming with IP precedency value 5, or let's say 4. Rest of the traffics are coming with the normal behavior, or let's say STTP is coming as 2. So in case of congestion, your priority will be given to your SMTP, then STTP, then other traffic will be given to the similar kind of distribution. So higher priority traffic will be served first in weighted fair queuing, although the traffic will be as per the flow. As again, it will create your what queue as per the flow. But now let's say my SMTP is 3 MB and STTP is 5 MB, telnet is 1 MB. So now the bandwidth allocation will be in behalf of SMTP because it is having the higher priority. So it will be given first to the SMTP, second to your STTP, then it will be equally divided into the telnet and FTP. Okay. So there is no limit of the queue, but it depends again how many. So iOS version as well as your interface, what kind of interface you are using. So as per flow, so if I have defined 16 flow as per interface, okay, and you are receiving 17, 18 or maybe 20 flows, the flow will be overwritten then. Okay, so this is how it works. One second. So flow will be overwrite over the existing flows or existing queues basically. So similarly we have CBWFQ. It's called hierarchical queue, or uh, recommended for voice is LLQ. So LLQ I would say, because it provides you the bandwidth and delay guarantee. So you can use that for the voice as well, right? Okay, let's talk about the little bit about the CBFQ. CBFQ. So this is called class-based weighted fair queuing. Okay, so queuing mechanism will be same, but you can define your bandwidth. Okay, so weighted fair queue again, there is no delay guarantee and bandwidth guarantee, so it is not recommended for voice. Okay, classification will be class based, as name is saying. Class based. Number of queue, it can use it will be up to 256 classes. Okay, so this is what we can say. Okay, bandwidth guarantee will provide bandwidth guarantee, but there is no delay guarantee. It's not recommended for voice. The benefit of class based weighted fair queue, I missed W here. So class based weighted fair queue is you can create multiple uh, queues over here, and as per the class you can provide the guaranteed bandwidth. So let's say you have some priority traffic of SMTP, let's say your HTTP and so on. So you can give either bandwidth in bit per second or kbps or bandwidth percent as well. Okay, but rest of the default class, there will be one default class where it will run weighted fair queuing, or you can run the weighted fair queuing within the class as well, right? So we'll check hierarchical queuing with the class based weighted fair queuing, how to do it. Okay, the last one which I want to describe, it's very important, LLQ. So it no we generally call it low latency queue. Okay, it again provides you the classification base, class based classification. So you can create the different classes. Generally we call it the combination of priority queue plus CBWFQ. PQ plus CBWFQ. So remember what priority queue was providing. It was providing delay guarantee. This is the only one. And CBWFQ was providing you bandwidth guarantee. So it means if we combine both, we'll get the best queuing mechanism. Okay, so priority queuing is strict. So for one queue, so one priority queue plus rest of the CBWFQ. So we can define that one queue for the voice. So let's say we have defined 40% of bandwidth to the voice and rest of the bandwidth is equally dividing as per the flow. So that will help us to provide bandwidth guarantee to the protocols as well as your strict priority to the voice and other sensitive, delay sensitive protocols, right? So